Good morning, good afternoon, respectively, everybody. Welcome to our SOS webinar. Today's webinar is focused on UDOO, and topic is real-time image analysis and physical computing with UDOO. Today's presenter will be Michelangelo Guarise, and at the beginning, I would like to say that the whole webinar will be recorded, and next week you can find this record at our webpage. At the beginning, before I pass word to Michelangelo, just a couple organization things. First of all, I would like to ask you if you have any question regarding the WebEx, please contact me. I will be your admin for today via chat. And also, if you have any if you have any question for presenter, please write it to Q&A window, and during the webinar, Michelangelo will answer this question. Also, all the participants will be able to purchase autofocus camera from UDOO with discount 25%. So after this webinar, I will send you an email with the offer, and it's up to you if you will like to use this chance and order this autofocus camera with this special discount. So now I would like to pass word to Michelangelo to start his presentation.
Okay, thank you, Miriam.
Okay, so now you can start with your presentation.
Okay, can you hear me?
Yes, I can hear you.
Okay, great. So I am quite happy to be back with SOS Electronics. We had a really nice webinar last time. Hope that if there is someone of you which attended, I hope they enjoyed it. Today we are going to dig a little bit deeper. We are trying to go on something that we exploited. To recap, if some of you didn't attend the last webinar, UDOO is a single board computer, a very powerful one, which can run Linux.
Michelangelo, may I disturb you for a second? But there is no presentation on the screen, so I don't know if you already shared it.
No, I'm just picking as of now.
Okay. Okay,
so,
sorry.
No problem. But anyway, can you see now on the screen?
Yes, now we can see it. Okay.
So to recap, UDOO is a single board computer, a very powerful one. Today we are going to use the quad-core version, and the incredible thing about UDOO is that it features also on the board. To robotics, domotics, and advanced physical computing. And today we are going to see exactly that, advanced physical computing. So what we're going to do, I'm going to show you briefly what we are going to see. Just give me a second. Okay, you should see now a YouTube video. Is it right?
Yes, we can see it.
Okay. So
Michelangelo, but we can hear any sound right now. Probably you should share this video or like a file, not like a application, because there is no sound right now.
It adds. Okay, now you should see a screen.
Michelangelo, we still cannot hear you, and so there we cannot hear. We can only see the screen, but
You cannot
also
hear me?
yeah, and now we can hear you really weak.
Weak.
Yes.
Okay, I will try to speak louder.
Okay, but maybe maybe there is something with the microphone, because sometimes it's too loud and sometimes it's too low. So maybe only please try to adjust your microphone.
Yeah,
Now it's clear. Now it's clear. It's okay.
Okay, great. So what we need to make the little project I showed you. So basically we use UDOO, our single board computer. We used the camera module of UDOO, which you can buy from SOS at a discounted price for today, if I don't, if I'm not wrong, right, Miriam, today?
Yes, you are right.
Okay, great. So I suggest you to do it after you see it, because it's really awesome what you can do. Then we needed 2 servo motors. I can show you the bills of material. And you need, of course, a place where to mount all of it. So let's see from the agro side what we did. I will just explain this to you. I don't have images for this. I'm sorry about that. But what you basically need is to connect the 2 motors to the Arduino side of UDOO. So you see we connected via these pins our motors to UDOO, to the Arduino side. Then we connected our LCD screen to the LVDS port. These screens are designed to be just plug and play with UDOO, so you are just meant to attach them and they will work. Then we attach the CSI camera module to the camera connector on UDOO board. Then we go to the software side. So the wiring is pretty simple. Connect the servo motors to UDOO, connect the LVDS touch panel, and connect the CSI cable. So now what you can see here is UDOO's official operating system. It's based on Ubuntu with a lightweight graphical user interface. Can you see it? And it comes with basically an anti-test editor for development, the code development, and integrated Arduino. So to do this project, what we use, we split in 2 parts. The first one relates to OpenCv, which for the one of you that doesn't know, is an open source library for image processing. And you can find it integrated in the tools of UDOO. you see, we have OpenCv examples. These are just examples which are meant to show what you can do basically with OpenCv. There are quite a lot of examples. So if we want to try one, we choose Edge, and we give the video source. When you use the UDOO camera module, you basically select 7 as your video source, because the UDOO camera module will work this way. So, if I run it, you can see basically me, because I'm sitting near the camera, and UDOO and OpenCv are processing in real time the image. So I'm capturing a video stream with the UDOO camera, and I'm applying some computation to it. Of course, this is variable. As you can see, I can change the way the computation happens. And I'm doing this in real time, just to show you how powerful UDOO is. In the meantime, I'm streaming the video you see from UDOO to my computer remotely through VNC. So, as you can see, you have already OpenCv included in UDOO. And there are also other examples you can use to see what you can do with OpenCv. You can do pretty much a lot of stuff from item definition, base recognition, movement tracking, and it is all meant to work. So, we are going to use for this project OpenCv. And this will be on, let's say, on our Linux side, because it will run on Ubuntu, as you can see. But, as you know, we also have on UDOO an integrated Arduino controller. And we are going to use that to move the motors, the servo that are attached to our board, and to make the screen move according to our face movement. Is this clear? Do you have any questions?
So far, there is no question, but as we have some comments that the volume of your voice is really going up and down. So if you can just adjust this microphone connection, because sometimes you are able to hear very loud and sometimes very low.
Okay. Suppose the microphone is adjusting himself by its own. So
Okay.
if I can do something.
Because sometimes it's really, really hardly to hear you.
Okay. I cannot adjust volume. If I adjust, it goes down automatically or goes up. Can you hear me good now?
Now I can hear you good, so hopefully it keeps on this level.
Please let me know if my voice fades.
Okay.
I don't know how to turn off the automatic.
Now your voice went low.
Yeah, I saw it going down.
Okay, but we are still able to hear you right now. So, but if it's possible to adjust this level.
No, yeah, I'm trying to. Let me check. Okay, so let's go on and see. Please let me know whenever my voice goes down. I will manually change the volume, okay?
Okay.
So, this is the first part. So the software which runs on the Linux side. Of course, we need also to control the motors somehow, and we are going to use the Arduino side of UDOO. The trick for doing that is using the serial communication between the two processors. So we have a serial device which is called Dev TTY MX63. On this device, we can send and receive commands both from the UDOO part and the Arduino part of UDOO. So the first thing we need to do, of course, is to create our service in Servo and track our code. To do this, we're going to use Python this time. Python is really handy in this situation because it's quite easy to read and to write. Furthermore, now can you hear me?
Yes, now I can hear you. But in the second it go down this voice.
Automatically, and I cannot turn off.
So maybe only make your microphone in the same position and same distance, and it might be helpful. Okay.
Okay, so first thing we need to do is install Python. Once you install Python, we need also to install pip, which is the package manager for Python. We can tell it install and for this project and in UDOO in general, one really useful thing is using PySerial. PySerial is a library which allows Python to communicate through serial interfaces. And using PySerial, then we can configure our serial interface to use the TTI and port. So our program will be setting the right serial port at the right output, which is 115 and 2. So once we've done that, we are checking if the serial port is open, because it might be used by other applications. Then we are going to set the video source, which is our video source. Of course, as I told you before, the right video source, video number for our camera is 7. Now, since OpenCv is quite a power-demanding application, we are not use a full HD resolution, or let's say an high resolution. We're going to strip it down to 340 after 240 in order to obtain an optimal balance between resolution and computational speed, of course. Then we are setting up here and here our cascade power. We're going to see later on, we'll share all the code with you, that we have this air cascade of XML, which is basically a bunch of parameters which is basically telling him how to process the image we are giving to him. So, if we look at this file, we're going to see that there are a bunch of values, a bunch of. So basically, we use the values and position to properly set how to move our motors, our servo motors. So, going on with the Python sketch, here then we are telling him to write a rectangle around the face it will capture, basing, of course, himself on the parameters we gave him with the R-Cascade classifier. So, this is the first part. So, running a Python application which reads from the webcam and computes, basing himself to some parameters we gave, where is our face, and drawing a rectangle around our face. Now, we must, of course, set up an Arduino sketch. For the one who knows Arduino, basically just write an Arduino sketch on the integrated Arduino on UDOO. So, analyzing this sketch, we include a Servo library. We just declare the pins that are controlling the two servo motors. One is on pin 2 and one is on pin 3. And then we initialize our serial interface. You see that the baud rate is exactly the same that we used for in our Python program. Because if we set this baud rate at different things, of course, we are not going to have communication, extra communication, just noise between the two. And here we are just reading data which is sent from our Python application, and we write them into Servo. So Python application values sent via stereo, so we are then writing into the appropriate Servo position. Okay, can you hear me now?
Yes, now we can hear you.
Okay. Do you have any advice where I can find how to turn off automatic volume?
It should be in the main menu on the main page, and there is a in this communicate and speaker microphone updated, and there you should be able to adjust your microphone.
No, I cannot get there. Let me unshare for a moment. I tried to change my microphone. I'm sorry for this inconvenience.
Can you see?
Okay, now I turned off the automatic. Now we should go on. Nice.
Now we can hear you okay, so hopefully stay on.
Okay, so we are going on perfectly. So if something did not sound clear to you, feel free to post questions. Please, Miriam, report whenever there are questions, and we'll go back.
Okay. So far we don't have any questions, so we can continue.
Okay, great. So, what we are doing then is sending the appropriate commands to the motors accordingly, so to our Python sketch. So this demonstrates that we are going to use two different and independent systems, one on Linux and one on Arduino, to achieve a single task. Okay? So now we can launch our face tracking. Of course, I have a shell script on my desktop, which is tracking.sh. I'll let you see it. So basically, what it does is launch through Python our webcam Pi application, which we saw before, and it gives him the appropriate Cascade XML file, which is telling him how to process the image. So if I launch tracking.sh, now you should see the video capture, and it is getting my face in real time. You see that the camera is moving. Of course, the lighting conditions are not ideal now, but it is getting my face and it is moving accordingly, thanks to the communication between Arduino and Python. If you are curious to see how much computational power we have left, let's see top. So basically, while I'm doing all of this operation, we have a really low load average. You see 1.40, while the maximum is 4. So actually, we have plenty of power left. And the most demanding application we have now is Python, of course, because this is where the code is running, and we have 90% CPU time. And consider also we are using BNC to stream this one here. So basically, this is what we did and what we achieved with this. So let's make it move again. Okay, got me. Probably headphones are quite messing up with the parameters we gave him. So, if you want to find the complete source code to make this project, and it is really nice also to start developing your own OpenCv applications with UDOO, we have then on GitHub. So this is the complete tutorial, which explains basically what I showed you right now. and you can also download the full source code for this application. So, are there any questions?
No, there is no question so far.
Okay. So, this was it. I showed you how to use motors in conjunction with OpenCv on UDOO and Linux. But of course, there are also other implementations. You can use OpenCv on Android, but of course, this is something which is quite different from this. But in general, you can use UDOO to perform heavy operational tasks in conjunction with real-time physical computing using both processors. And so I would really like to discuss with you if you have some projects which you would like to do this way with OpenCv or with other frameworks we can discuss now. So please, if you have, if you want to discuss some project, please write it, and I will reply, and we will discuss about it.
Okay, so far we don't have any question or any. Okay, there is for sure.
Okay, let's see.
If you add some technical details, which processor you use and so on.
Okay, okay. I will explain probably. I will let you see all the full specification of UDOO. Let me find it. Okay. Okay, can you see the presentation?
Yes, we can see it.
Okay. Okay, so just to let you have an overview of the board, probably you asked about the microcontroller. The microcontroller is the ARM SAM3X microcontroller, which is the same one you will find on an Arduino Duo. And we have 56 GPIOs, which are shared both for both processors. And the main processor, the Linux one, is an MX6 processor from Freescale. It comes in dual or quad core, and they share both GPIOs. So you can access the GPIOs both on IMX side or from the Arduino side, from the SAM3X. So basically, this is the controller, the microcontroller of the board. I hope this was your question.
Okay, thank you for answer. And there is no question so far, but also I would like to say if there is any question after this webinar regarding the project you would like to discuss with Michelangelo, you can feel free to write us, and we'll pass also this question to Michelangelo to contact you and answer. And now we have some other questions.
Yeah.
So how is made assessed from those two processors?
Okay, okay, yeah, probably I was explaining in the initial part of the presentation. I will repeat and probably give an overview of the board, since probably someone may have missed the last time what we were talking about. So I will introduce to UDOO. Okay. So wait a second. Okay, so I can give you an overview of the board. Okay, you can see my browser right now.
Yes, we can see.
Okay, so from the top you see all the connectors that we have, and you see also the Atmer processor, which is on the middle on the top, and then the big heatsink on the bottom is the other processor, the Linux one. Speaking about I/Os, we have microphone and audio out, 2 per USB. We have a gigabit Ethernet, HDMI. Then we have 2 USB debug ports, which are really useful, both for programming the Arduino from the outside and for accessing the bug informations. Then we have an additional USB, Wi-Fi module, and the micro SD, where the actual system resides. So this is basically the hard disk of UDOO. And then we have 56 GPIOs. I will show you now how these 2 processors communicates. You can see in this picture that is more clear. The red one is the Linux processor, so the quad-core or dual-core processor, which has its own GPIO, which are marked in red. The blue one, instead, is the Arduino SAM3X processor, which is marked in blue. Some of these GPIOs are shared. So how do they communicate? I had a nice picture, I cannot find it now. However, they communicate via an internal serial communication. So there is a serial bus which connects these 2 processors. So to make them talk, we can say, they can talk also in bidirectional mode, so they can both send and receive data one from each other. We just need to configure the serial communication on both processors on the same baud rate. So in the previous example, we configured it to 115 and 200 for both processors. So basically, it's like when you connect your Arduino to your PC, you are using a serial communication. In this scenario, with UDOO, the serial communication is built in. These 2 processors are connecting each other via a serial communication. This happens on Linux. On Android, instead, we do use the Google Accessory Development Kit, the ADK, which is meant to connect Arduino to Android phones. Okay, so we implement it, and this serial device is seen as an accessory. So you can use your Arduino as it was a normal accessory on Android. And so basically we can use these 2 processors independently. We cannot care about using them 2 together. For example, we can just run a Linux application and control GPIOs through it. We can also use just the Arduino processor and run a simple sketch like we do usually on Arduino, or we can use them combined. for example, reading data from sensors, temperature from Arduino, and sending them to Linux via serial and displaying, for example, via a server, or sending values to Arduino from Linux, for example, to move motors, like we did this time with this example. I hope I did reply to your question. If not, write in chat. You are, yes.
Okay, so next question is, oh yeah, I guess you already answered that you
Yeah.
Okay, so I don't see any further questions, so if you can continue, we can continue.
Yeah, GPIO pins are controlled directly from the Atmel processor, and they are controlled also from the IMX6 processor. So you can choose, you can see there are two different, they are controlled by both processors. And you control, of course, one GPIO with one processor at a time. So it's really up to you. You can use them as normal GPIOs, or you can use them as Arduino pins. If you use via Arduino pins, you should, of course, use the serial communication to write data from Linux to the Atmel processor.
Okay, thank you for your answer. So please, if you have any further question, write it down. Yes, there is one more question. Pins are physically connected to Atmel?
Yeah, they are physically connected both to Atmel and to IMX6. If you can see the picture I am showing you now, these are actually physical connections. There is no software layer involved.
Okay, thank you for the answer.
You can find also nice information on our user manual, which has also all the schematics. So let me show you. Of course, on UDOO.org, we've made our best to release all the information you may need, both on software, like you see all the software, all the projects we made are open source, and we release all the code. And also, it's open source hardware, so you can access basically every information regarding schematics. Okay. So you can see on documentation, we have UDOO starting manual. You can find also the mechanical specs and the schematics. And also pinout diagram, which is really useful. So this is the complete pinout diagram when you can see what functions you can give to the pins, both from the Arduino and both from the IMX6 controller. So, for example, let's take, for example, PWM1 and PWM2, which are here. They can be used also as GPIO 9 or GPIO 1. GPIO, of course, is the naming of the GPIOs when they are used by the IMX6 processor, and PWM1 and PWM2 are the names which are used when they are used by the Atmel. And so you can find also the physical pins descriptions and functions also in this table. and all the complete schematics are also available, so you can dig pretty much with all the detail you want through our schematics. So, if there are not other questions.
Yes, we still have some other questions.
Okay.
I'm not sure if you answered this one. How can you switch which processor control GPIO pins?
What? Can you repeat, please?
How can you switch which processor controls GPIO pins?
Well, actually, you don't need to switch. So if you use a pin with the IMX6, so with the Linux processor, it will be automatically used as a GPIO. If you use it as Arduino pin, it will be automatically used as Arduino pin. This, of course, means you should be, let's say, careful not to trigger the same pin with IMX6 and Arduino on the same time, especially setting one as output and the other one as an input with different voltages. So we decided to give all the freedom that comes from this situation, but of course this means you should be aware that there is the risk of destroying the board if you misuse it. And there is a good explanation of this mechanism in our wiki where I showed you before. Let me find it again. Okay. As you can see here, warning, set up the same pin on different states at the same time, or controlling it at the same time with both IMX and some tricks will result in damaging your board. So we are giving flexibility because you don't necessarily have to switch between GPIOs or Arduino pins. You just use it as you want, but don't use the same pin with both processors at the same time. So I see another question in chat. Is there any protection to prevent this to happen? No, because this would have meant additional circuitry, and of course, if you're going to use this, means you are quite an advanced user, and you should, understand that this could be a problem, and we wrote actually loud and clear that you must avoid this situation. Okay.
Okay, thank you very much for the answer. So, still, if you have some questions, feel free to write this question down. Okay.
In the meantime, I'm telling you that we recently released our camera module, also in two fashions, with or without IR filter. So you can use also for projects which involves IR recognition, like night vision, for example. And I'm really eager to see what you guys can come up with UDOO and its camera and OpenCv.
Okay, so we don't have any further questions. So I would like to remind you at the end of this webinar the special offer for autofocus camera with a 25 discount. I will send you email with this offer after webinar. So this offer is valid 1 week, so it will be valid till 18 December, and you can order. And also, this webinar is our last webinar in this year, so I would really like to thank you for your attention and for attending this webinar. And I will be really glad to see you at our next webinar in next year. And of course, I would like to say thank you to Michelangelo for holding this webinar and share information with us.
You're welcome, Miriam. It was really great for us to be hosted here, and thank you, of course, to SOS Electronics. Thanks to you guys which attended this, and please join also our forum where you can find a lot of information about the project we explained today and the other one that we made it. And hope you will spend a nice Christmas and a really good New Year. So thank you, everyone. Thank you, Miriam.
Okay, so thank you very much one more time. And also, just one last reminder, whole webinar can be found at our webpage during next week. And also, if there is any further question for Michelangelo, feel free to write out, and we will forward this question to Michelangelo. So thank you one more time for your time, and looking forward to meet you at our next webinar. Have a nice day.
Yeah, me too. Have a nice day. Bye. Bye, everyone. Bye.